Good day, everyone. I am Charmy Ponte, and today I will be talking about grounded and ungrounded conductors under Chapter 19.4. What is grounding? Grounding or electrical grounding is a backup path that provides an alternative way for the current to return to the ground in the event of a fault in the wiring system. It facilitates a physical connection between the ground and electrical appliances and devices in your homes and yours. It says here that grounding is an alternative way for the current if a certain appliance has overloading or short circuit. This grounding will help the current to flow to the ground. So we have here an illustration. The washing machine here might have fault in its system that causes na magkaroon of overloading or short circuit. If that faulty current is walay magtuan and magstay lang siya sa washing machine, it might cause an electric shock kung kinsa man ang magunit sa washing machine. But same in this picture, the man touched the washing machine that caused him to electric shock, to cause him na makuryentehan. But if there is grounding in this picture or in a situation like this, the faulty current will flow back to the ground. The faulty current will flow back to the ground without causing any problem. So, and take note that grounding is a backup pathway that is only used if there is fault in the wiring system. So, kung wala may problema or any fault sa circuit, is dili na siya need kay naman tay mga original conductors sa itong circuit na sila nang bahala sa electric current from source pa to some appliances back to the ground or source, creating a cycle. So that is the meaning and the purpose of grounding. Now let's move on to the grounded and ungrounded conductors. Grounded and ungrounded conductors are necessary to complete an electric circuit. They provide a continuous path from the load to ground. Both conductors are connected to the earth, but there are differences in the location and the function of each of these conductors. When we say conductors, it is a substance or material that allows electricity to flow through it. Examples are the wire or any other materials such as copper, silver, aluminum, or any materials na pwede madaluyan sa electric current. Grounded and ungrounded conductors complete the electric circuit or cycle because these conductors carries the load from the source to any appliances back to the ground or to its source. These conductors now is connected to the earth, but they have different functions. Later on, we will further understand their differences and their functions. Grounded conductors. Grounded conductors is a system or a circuit conductors that is intentionally grounded or attached in earth. So grounded conductors provide a safe path for ground fault current to flow. So simply said, grounded conductors is a conductors that is connected to the earth. As I said kanina about sa grounding provides an alternative way sa faulty current to flow pabalik sa ground or source para di siya mag-cause og shock or worse. So, grounded conductors are used as a path for the faulty current to flow. We have two types of branch circuit under grounded conductors. First is the single-phase branch circuit. A grounded conductor serves as the grounded leg of the circuit. It completes the circuit by connecting the undergrounded. It completes the circuit by connecting the ungrounded hot conductors to the ground. Thus, in circuit design, the grounded conductor is considered to be a current carrying conductor because it serves as a return path back to the circuit's power source. So, from the name itself, single, this branch circuit only have one circuit that we can utilize during its cycles. Usually, single-phase branch circuit are used in residential buildings since it only gives 220 volts volts that is usually distributed in the residential building. So a single-phase branch circuit simply is a single ungrounded wire. Ano na siya. I have here a single branch circuits flow here. First, we have a live load or ungrounded load nga ginadistribute sa residential building to reach ang mga appliances just like the TV, in here. Then the excess electric current or the grounded load will flow in two direction. It's either it will flow in the neutral conductors that here, the neutral conductors that will bring back the current to its source. Or if there is a fault in the wiring system, the electric current will flow in the grounded conductors to bring the current to the ground. We call this process grounding or earthing. Take note that grounded and neutral conductors are connected but has different purpose. Grounded flow the current to earth, or that's what we call grounding, while the neutral carries the current back to its source to complete the circuit. So again, ang single-phase branch circuit is na lang siya isa ka wire nga ungrounded load paadto sa atong appliances, and then for appliances mugawas siya. It's either moadto siya sa ground if this current is faulty or short circuit or overload, moadto siya sa earth. But it really is mobalik siya moadto siya sa neutral pabalik sa source, creating a cycle. Next type is the two-wire branch circuit. The grounded conductor carries current equal to the load. If the ungrounded or hot conductors is feeding a load of 12 ampere, then the grounded conductors carries 12 ampere to the ground. As a result, the grounded conductors must be sized at the same ampacity of the ungrounded or hot conductors. So two-wire branch circuit, we have two wires for ungrounded or hot conductors. These two wires usually divided the current. Divided the current. For example, we have 220 volts in this branch circuit. So ang mahitay po is each wire will divide the 220 volt na, so 110 na lang voltage na lang ang ilang ginabit each wire. And also kung unsa daw ang load nga ginadala sa ungrounded conductors, same sila sa ampacity nga dalahon sa grounded conductors. I have here the illustration of the two-wire branch circuit. Same lang ni sila sa example that I presented in the single wire circuit. Ang pinagkaiba lang is we have two wires for the ungrounded load. We have 12 ampere here. This 12 ampere will be divided in two. So each wire will carry the same load of electricity, will carry the same or even load of electricity. These two wires will flow to the appliances, then to the grounded load. It will either back to the source using the neutral conductor or back to the ground using the grounding process. So let's do first a recap before proceeding in the next subtopic. Grounded conductors is a wire or conductor that is connected to the earth. It carries faulty current back to the ground. So it will prevent any electric shock nga mahitabo or problems. While the ungrounded conductors is a wire that carries the load or electricity that will be distributed throughout the building. So that's their differences. Next is, I have mentioned neutral conductors earlier, pero short lang kayo siya, so let's further talk about neutral conductors. Neutral wire conductor is used to carry the circuit back to the original power source. Since electric flow is a cycle and we cannot complete the cycle if the current will not go back to its source, it is the work of the neutral conductors to carry the electricity from any appliances back to its source, again complete the cycle. A neutral conductor performs the functions of a grounded conductor for at least two ungrounded hot conductors that have sources from different voltage phases, such as on the multi-wire branch circuit, multi-wire feeder, and electrical service. Neutral conductors daw is gaakod siya as grounded conductors if we have at least two ungrounded conductors from any source. Shared neutral or common neutral is a neutral conductor that is a grounded conductor that is shared between two or more ungrounded conductors. Mao na siya akong ginaingon nga ang neutral is gaako siya as grounded conductors when we have at least two conductors. Ginatawag siya nga shared neutral because gina-share siya sa two or more ungrounded conductors. I have here the illustration how neutral conductor works. We have here a source of electricity. Moagi siya sa atong ungrounded conductors. Ginatawag nato ni siya nga live wire hangtod sa appliances. Sa appliances nato, if there is faulty in wiring, is diri siya moagi kaning green na wire from equipment case to Mother Earth. If there is faulty current, but if wala, ang atong electricity is moagi lang siya sa neutral conductor back to its source or kaning sa current supply. Muna ang ginatawag nga karing wire from neutral to Mother Earth is man akong ginaano nga when the neutral conductors is gaakod siya as grounded conductors. The black here signifies the neutral, the green represents the earth, and the red represents the live load. Another example is this. Ang atong source dari is ang battery. Ang kaning battery, ang current niya is magi siya dari sa ungrounded conductors, ginatawag na to nga hot wire hanggang sa maglight na ning lamp. Magamit na nato siya, and then magawas na pud ang electricity moagi siya sa neutral wire back to its source. Tapos diri na pud balik na pud siya, creating a cycle hangtod sa maubos ang life sa battery. So that's how neutral conductor works. I have here a table para mas dali na ito masabtan para mas dali na ito ma-differentiate ang tatlo. Under ungrounded conductors, or what we call live wire, is connected directly to the generator of the power station. While the neutral conductors or the neutral wire returns the electricity to the generators by completing the circle. So, neutral wire is ginabalik na daw ang electricity sa source niya. Ungrounded conductors or ginatawag nato nga earth wire doesn't carry electricity. It is used to prevent people from getting electric shock. So, mo lang yung purpose sa atong grounded conductors. If there is a faulty in our current, pwede siya mag-cause electric shock, but tungod sa grounding is ma-prevent na siya. Voltage of a live wire is same as the main supply, while the voltage of a neutral wire is approximately 0 voltage. Since earth wire is not connected to the earth, its voltage is 0. So that is their differences. In here, we have a few important information. A hot circuit is potentially a hazardous condition because it unnecessarily exposes occupants to hot wirings. It simply means that any exposed wiring daw is hazardous, especially if it carries hot load or electricity. Second, interruption of the grounded or neutral conductors with a circuit breaker, fuse, or switch is considered poor practice in most instances. The wiring system or cycle should not be interrupted or have any instances that might interrupt the cycle, or else it is considered poor practice, so mali na siya. The circuit should be protected with a circuit breaker or fuse in the grounded wire. All wiring system or circuit should be protected by circuit breaker. A circuit breaker is an electric switch designed to protect an electric circuit from damage caused by overcurrent, overload, or short circuit. Next is the flow of current from the substation. Ang substation nato dere, for example, here in Jensen, we have Socoteco. From substation, madun siya mga poste, mga tatong source, magit siya sa transformer, and then sa atong transformer, moagi siya sa atong hot, kaning hot, dere siya moagi sa tuang ungrounded conductors, natawag nato ni siya nga hot wire or load wire. Tapos, moagi siya dere, and then, pag magamit na nato siya, magamit na nato ang appliances, mogawa sa pud ang electricity and moagi siya sa neutral conductors back to its source, there is a transformer. Ang diri sa akong gibulugan, ginatawag nato ni siya nga service drop. Mo ni siya when the electricity is being distributed from house to house or from poste padto sa mga residential subdivision. And ang atuang ano po daw, atong source po daw is it is connected to ground because syempre ano po na siya, gabitud na siya gwar, so it is possible that there is a faulty wirings or faulty current na mag-occur. So to prevent that, it is connected to the earth. So this is the flow of the current from the substation gikan sa atong source. Halimbawa, sa Coteco, moagi siya sa ungrounded conductors, magamit nato ang appliances, and then it will go back to its source gamit ang neutral conductors. So I hope you understand it. Next we have another topic for this chapter is the load balancing. Load balancing is a practice used when we have two or more ungrounded conductors. Loads are divided between A and B when we have two ungrounded, and X and Y and Z legs when we have three wires of ungrounded. It is important na sa isa ka circuit dapat balance yun siya nga loads ang ginadala nila, or else it will cause a fault or problem in the wiring system. For example, we have 18 ampere. It will be divided in two. So each wire will carry 9 ampere na lang. So that's what we call load balancing. I have here an illustration of the balance load. From the source, it is divided. We have here balanced load. From the source nato natay 240 voltage. From the source nato moadto siya, since we have two ungrounded wire, it will be divided in two. So each ungrounded conductors will carry 120 voltage. Padto sa atong appliances, and padto sa atong appliances, mobalik siya sa atong neutral conductors pabalik sa ato ang so mao lang ang ginatuang nato ma-balance load when we have at least two or more ungrounded conductors. Dapat balance ilang load nga ginadala, and it is evenly the voltage and the ampere is evenly distributed in each conductors. Next is the unbalanced load. Unbalanced load naman is when the loads in the grounded conductors are not balanced. For example, the conductor A carries 10 ampere and then the conductor B carries 13 ampere. So unbalanced siya. So that is the situation nga unbalanced load. We have here a solving nga paano nato ma-determine ang unbalanced load. Example 19.1, the neutral load on a 120 to over 240 voltage 3-wire feeder circuit carries an unbalanced load on the ungrounded conductors of 68 ampere. On phase A and 58 ampere on the phase B. Determine the ungrounded neutral conductors. So to get the unbalanced load, we simply have to minus the phase A to phase B. So 68 ampere minus 58 ampere is equals to 10 ampere. So atong unbalanced load diri is 10 ampere. 10 ampere nga ginadala sa ato ang neutral conductors. But it is important nga dapat balance gyud ato ang load when we have at least two or more conductors to avoid any problems. And that's the end of my report. I hope you understand. But so uh, so maybe we can do a recap first. That's the end, but let's do a recap first. Grounded conductors is a conductors that is grounded or connected to the earth. Ungrounded conductors, it carries the load from the source to appliances. Neutral conductors carries the used electricity or the electricity pabalik sa ato ang source, creating a cycle. So that's the end of our report. Thank you for listening.